this video, we are going to discuss about kinematics of rectilinear motion. Our learning objective is to understand what is rectilinear motion and to find out kinematic quantities such as position, displacement, velocity, acceleration and time. In this video, we are going to cover topics: introduction, position and displacement, velocity, acceleration, type of motion, kinematic equation for uniform acceleration motion, motion under gravity. So, what is kinematics? Kinematics is a branch of mechanics which deals with the study of motion of the objects without considering cause of motion of that object, that is force. We know to move any object we require a force, but in the analysis of motion in kinematics we do not consider the force which causes the motion. So what is motion? Motion is nothing but the change in position as shown in the figure. At instant t equal to 0, the position of a particle is 0, and at time t it moves to a second position, that is 1. So this change in position is called as motion. Rectilinear motion. In rectilinear motion, linear, the word linear says line. So rectilinear motion is a motion along straight line. For example, a train moving on a straight track. There are variables involved in kinematics of rectilinear motion. Position, the straight line path of the particle can be defined using single coordinate axis as shown in the figure. At time t equal to 0, the position of particle is x equal to 0, but after time t, the particle is at the position x. So this 0 and x represent the position of the particle. Displacement. The change in position of the particle is known as displacement. For example, if the particle moves from P to P dash, as shown in the figure, so the displacement of that particle is given by delta S, S dash minus S. Here, S dash is the positive since the particle's final position is towards right with respect to origin. Likewise, if the final position were to the left of its initial position, delta S would be negative. Velocity. Velocity is nothing but the rate of change of displacement. If the particle moves through a displacement delta r from P to P dash during time interval delta t, as shown in figure, the average velocity of particle is given by delta r upon delta t, or considering v as algebraic scalar, we can write v is equal to ds upon dt. Average velocity or mean velocity of the body is the velocity with which the distance travelled by the body in the same interval of time is same as that of its variable velocity. The average velocity of particle is given by initial velocity u plus final velocity v divided by 2, and displacement s is given by u plus v divided by 2 into t. Since delta t is always positive, delta t means smaller time, so t is always positive. The sign or direction of velocity depends on ds or delta s. When delta s is positive, the particle is moving toward right and the velocity is also positive. When delta s is negative, it indicates that the position of particle towards left and the velocity is negative. Acceleration. The rate of change of velocity with respect to time is known as acceleration. When the particle moves from P to P dash. If v is the velocity of particle at P and v dash is the velocity of the particle at P dash, then the average acceleration during the time delta t is given by delta V upon delta T, that is V dash minus V divided by T dash minus T. The instantaneous acceleration at time t is found by taking smaller and smaller values of delta t and the corresponding smaller and smaller values of delta v, so that we can write a is equal to limit of delta t tends to 0 delta v upon delta t, or using algebraic scalar we can write it as a equal to delta v upon delta t, or a is equal to d square s upon dt square. Acceleration will be negative when the particle is slowed down or its speed is decreasing. It is said to be deaccelerating. As well as acceleration will be negative when the particle is moving towards left with increasing speed as per sign conventions. Acceleration will be positive when particle is moving fast towards right or its speed is increasing. Acceleration will be zero when particle is moving with constant speed. Types of rectilinear motion. Uniform velocity motion. If the body travels equal distance in equal interval of time, it is said to be moving with uniform velocity. For example, if particle covers a distance of 1 kilometer in 5 minutes, in the next 5 minutes it will cover a distance of 2 kilometers. So that type of motion is called as uniform velocity motion. Uniform acceleration. When the velocity of a body changes by equal amount in equal interval of time, the body is said to move with uniform acceleration. For example, if the ball is thrown vertically down at any instant of time at any position, the velocity of particle is same. So that type of motion is uniform acceleration motion. Variable acceleration. When the velocity of a body changes by unequal amount in equal interval of time, the body is said to move with variable acceleration. In this video, we are emphasizing on uniform acceleration motion. Uniform acceleration motion can be analyzed by using three formulas which are derived as follows. The formulas are V equal to U plus AT. Second formula is V square equal to U square plus 2AS. S is equal to UT plus half AT square. Motion under gravity. When the particle is projected vertically in the air or it is thrown vertically down, then its motion is under action of gravitational force. The motion of particle under the action of gravitational force is known as motion under gravity. Characteristics of motion under gravity. Throughout the motion of particle, the gravitational acceleration is always in downward direction. So, G is equal to minus 9.81 meter per second square. Motion under gravity is uniform acceleration motion, as acceleration is always A equal to G. At maximum height, velocity must be 0. Please note the following points. As per our sign convention, we shall use all upward quantities as positive, all downward quantities as negative, as G is always downward, so A will be equal to always minus G. This is the